In this video, you are going to learn how to convert standard form into slope-intercept form. And we haven't really seen any equations in standard form because for the past bunch of videos, we've been really focusing on using slope-intercept form because that's really the form that you're going to want to see most of your linear equations in to make your life with graphing a little easier. So when you look at your standard form equations, you're going to see the x and the y on the same side, which you're now going to start seeing in class. You're going to start seeing equations in standard form and in slope-intercept form, and you're going to have to turn your standard form equations into slope-intercept form to make your graphing life easier. You could always graph using standard form, it's just going to take more time and it's going to be more annoying. So usually when we graph equations, we graph it using slope-intercept form because the intercept and the slope is right in front of us. So this video shows you how to go from standard form, where your x and y are on the same side, to slope-intercept, where it's y equals slope x plus or minus b. So we're given an equation in standard form, and if you look, the standard form formula, for lack of a better word, is ax plus by equals c, where a simply stands for the coefficient of x, and b simply stands for the coefficient of y, and c is a constant. And our goal is to be able to convert it into slope-intercept form, because slope-intercept form allows us to graph lines by just looking at the equation, whereas standard form will not allow us to do that. So when we look at the equation that I have written in standard form, our goal is to get y by itself, because in slope-intercept form, y is completely isolated. So in order to do that, I'm first going to move x. I'm going to move the whole term of x. So in order to do that, 4x is positive, so I'm going to subtract 4x, and I'm going to subtract 4x, and that's going to leave me with a 0 pair, and 2y is going to be alone on the left side of the equal sign, and then negative 4x plus 8 is going to be left on the right side. We can't put negative 4x and 8 together because they are not like terms. So now I have 2y isolated on the left side, but again, slope-intercept form just wants me to have y. So I'm going to have to divide both sides, and that would be every single term on both sides by 2 in order to get y by itself. And when I do that, I get y equals negative 2x plus 4. So the equation 4x plus 2y equals 8 is y equals negative 2x plus 4 in slope-intercept form. So this then allows us to identify our slope as negative 2 and our y-intercept as 4, and then graph the line 4x plus 2y equals 8. So I'm going to convert 6x minus 3y equals 15 into slope-intercept form, and I'm going to remember that slope-intercept form will have y completely isolated, and then the number in front of x will be my slope, and the number added to or subtracted from x will be my y-intercept, and this will allow us to graph in slope-intercept form using our intercept and slope. It'll also allow us to create an easier xy chart because we won't have to keep multiplying by 6 and then subtracting 6 times x when we do input-output. So our goal here is to convert 6x minus 3y equals 15 into slope-intercept form. So I'm going to go ahead and subtract 6x because I want to get y by itself. I'm going to get negative 3y equals negative 6x, and even though that looks like an 18 or a blob, it's really plus 15. And then I need to get y by itself, so I'm going to divide everything by negative 3, and the reason the 3 is negative is because there's a minus sign in front of the 3y, making the 3 negative. So when I divide everything by negative 3, I get y equals 2x minus 5. So that then tells me that my slope is 2. It's positive because negative divided by a negative is a positive, and my y-intercept is negative 5, which means I would start at 0, negative 5, and I would go up 2 and to the right 1 to graph my line. So here's another example. I'm going to subtract 4x from both sides to create a 0 pair, and I'm left with 8y equals negative 4x plus 16. When I divide everything, I divide it by 8, and I'm left with y equals negative 1/2 x, because negative 4/8 reduces, and we always reduce to lowest terms. plus 2. So that means my slope would be negative 1/2, and my y-intercept would be 2. So I'd start at 0, 2, and I would go up 1 into the left 2, or I'd go down 1 into the right 2. So in this case, I would subtract 1x from both sides. If you don't want to put the 1 there, that's totally fine. I'd be left with negative 4y equals negative 1x plus 8. The reason I like to put the 1 there is because now when I divide by negative 4, it's very apparent to me that that would be 1/4. And because this is a negative, then 1 is a negative and the 4 is a negative, the entire fraction turns positive. And then 8 divided by 4 is 2. So my slope would be positive 1/4, and my y-intercept would be 0, negative 2, or just negative 2. So sometimes the numbers aren't as pretty as the last few slides were, and it's okay if that happens, because sometimes either our y-intercept or our slope will be some sort of improper fraction. It's way easier to deal with when our slope is an improper fraction than our y-intercept, and at least in 7th grade, for now, you're not going to have y-intercepts that are fractions because it's too difficult to graph using slope-intercept form. So I'm going to move the 2x to the other side to isolate my y. I get negative 2x plus 9, and in order to fully isolate my y, I have to divide everything by 3. So I get y equals negative 2/3 x plus 3. So my slope is negative 2/3, and my y-intercept is 3.